In this video, I'm going to talk about completing the square and how and why we use it when we are solving quadratic equations. So we've already learned about the three different forms of equations. We've learned about our standard form, we've learned about our vertex form, and we've learned about our factored form. And we know which parts of the parabola it gives. Just as a reminder, we have our picture down here. And we are able to find vertex and our solutions, which are also called roots or intercepts. And with those 3 points, we are able to graph our parabola. And so that's what we're looking for, ways that we can find solutions, ways that we can find the vertex, and we can graph. And so when we have our factored form, that is the form that we typically like the most. So let's look at this example where we have x squared plus 4x plus 4. And so first and foremost, yes, this is in standard form. We can use our negative b over 2a shortcut to find the x value of our vertex. But we can also ask ourselves, what factors of 4 add up to be 4? And we can say, oh, that's 2 and 2, and so we could easily factor this. So then right away, we have negative b over 2a gives us negative 4 over 2, or our x value is located negative 2. We can plug it in, and we already have our vertex. We have our two intercepts. We are quickly able to graph this parabola, know what direction is headed, and have our main points. But what happens when we have something that we can't easily graph? What if we have x squared plus 4x plus 2? And so we look at our standard equation and we go, okay, it's in standard form. We could find our vertex. But when I ask myself, what factors of 2 add up to be 4? There are not any. And so we cannot easily put this in factored form. Therefore, we can't have our solutions easily for it. And it doesn't meet one of our forms over here very easily either. And so completing the square is an option where we can rewrite this equation into vertex form. And so when we ask the question, why would we use completing the square? We're going to use it to put the equation in vertex form. And so then we can know where our vertex is located, and we get a lot of information. We also know we can find our x and y intercepts rather easily for that one as well. And so how do we put the equation in vertex form? Well, first, let's look at vertex form and see what one of the defining factors of vertex form is. And if we look over at vertex form, we have this box here, and we have an x minus h binomial, and it is a quantity squared. And if we remember, that is called a perfect square trinomial. And what that will always do, and whether it's minus or plus, it will always give us the first term squared, 2 of the first and last term, and the last term squared. And then the signs are dependent upon what we have there in the middle. And so when we have this value, when we have a trinomial that is set up in a squared, a 2ab, and a b squared, we know that it factors back into this perfect square trinomial. So let's look over here at the trinomial that we have. We have x squared plus 4x plus 2 This is not a perfect square trinomial. And so what we are going to do with completing the square is we are going to force a perfect square trinomial. And there are a multitude of really great YouTube videos that show the steps for that. And I am going to approach this maybe a little different way of thinking, other than just the memorizing the steps of taking your b value in half and squaring it. So if we are looking at forcing a perfect square trinomial, we know, as we talked over here on the right, on the left, that this is going to be two binomials that are exactly the same, and they will turn into this predictable trinomial. So our problem over here is this 2. It doesn't allow us to factor it, and so we are going to get rid of it, and we're going to move it to the other side. And so remember, we are setting all of these equations equal to 0, so this y value is really 0. We've moved our 2 over. It changes signs whenever we change the side. And now we have an empty space where that constant lies, because that was the problem. We couldn't find a factor of 2 to add up to be 4. So let's think of where we are headed. We are trying to make this right side look like a perfect square trinomial, which means that we are going to have the same value in our first spots and the same value in our last spots here. Well, the first spot is always determined by our first term, and so it's x squared, so we know those guys have to be x. And our last spot is the guy that we're going to get to make up for it. And so let's think about it. In the middle, we have a 2ab. We have 2 of these guys. We've got the outsides. So when we look at FOIL, we have our first, which creates our x squared. Our outers and our inners are what create our 4, and then our last is going to create this n. So we have 2 different spots, x times something and x times something else. We have 2 of them that must add up to be 4. So we ask ourselves, what 2 numbers that are exactly the same add up to be 4? And we can say that's 2. 2 plus 2 adds up to be 4. And the signs are positive because our sign has to be positive 4. And so now visually we get to see we have 2 matching binomials that will create x plus 2 quantity squared. So we have now forced ourselves to have that quantity squared. But we're not done. So we know we have the correct binomials now. So now if we were to FOIL out, what number sits in this empty spot? Well, we have, according to FOIL, it's our last terms. So we have 2 times 2, and 2 times 2 is 4. So we put 4 in that last spot. Now, the trick is that with math, we always have to be fair to both sides. So if we added 4 to the right side, we also have to add 4 to the left side. And so what we get is a 2 over on the left side. And then we already know what this guy turns into. We have written it right here at the bottom. So 2 is equal to x plus 2 squared. Now we don't like to have it in this form, So we're going to move our 2 back over, and every time we change sides, we change the sign. We're going to call this f of x again, which is another name for y. And now we have our vertex form that has been created from our equation that originally started out as x squared plus 4x plus 2.